Hello, everybody. Thank you so much for coming. It's a beautiful weather and a beautiful campus, so thank you for spending your after lunch time here. I'm going to be talking about some of the work in personal informatics and development of solutions for personal health. Thank you for the introduction. It was pretty much covers every experience that I've had. I will mention that my original background was in shipbuilding engineering, which people find hilarious. Ask me later what the transition was like. But I did make a transition from CS and HCI into biomedical informatics, where I am now, and that kind of shapes a little bit my research. But a lot of the questions I ask are still about how people engage with technology in the space. So I will start by mentioning briefly the kinds of things that I will not be talking about, but will be happy to answer questions. Uh, Being in the medical school, a part of my work was and continues to be on understanding clinical work practices, particularly communication and collaboration among clinicians within patient care teams. I am listing some papers here. This was the work of my recently graduated PhD students. I will not be talking about any of this here, but I'm happy to answer questions. And a little bit earlier, I talked about some of the work on collective sense-making within online health communities. Again, this is a big part of what my research is focusing on, but this will be outside of the topic for this presentation. What I do want to talk about today is this big problem that this country and many countries around the world face is the continuous growth in chronic conditions and chronic diseases. By now, I think the statistics are well known to everybody. It continues to be a big challenge. And one of the big problems in chronic diseases is that they require continuous and proactive self-management from affected individuals. So here I'm listing 7 healthcare behaviors identified by the American Association of Diabetes Educators. Healthy eating, being active, monitoring, taking medication, problem solving, reducing risk, and healthy coping. So that's a relatively comprehensive set of activities that somebody with diabetes needs to engage in on a daily basis. And given the scale of this problem, there are a large number of efforts in many different communities to address this problem. Colombia has a wonderful Department of Public Health. There are a large number of public health initiatives that focus on communication, education. There are many technological solutions from both commercial side, the industry, and also the academia research on health technologies has grown exponentially within HCI and computer science as well. But what we see is that despite all these efforts, there are moderate impact and there are still relatively low levels of engagement. People find it difficult to engage with technologies for management of chronic conditions. Now, health behaviors is a large space and there's a lot of work going on from different sides, and it's also very rich theoretically space. So when you start thinking about technologies in health management, a good place to start is with theories of health behaviors. There exist many different theories. I find this particular one to be helpful not only because it suggests opportunities for where to intervene, but also it presents a relatively good way to think about kind of the directions for research and outline the space of solutions. So to engage in health behaviors, several preconditions need to be met. People need to understand what those behaviors are and be knowledgeable. They also need to be motivated and have a motivation to engage in those behaviors. They need to be able to translate this general knowledge into their specific behaviors and overcome barriers. And then all of this leads to engagement in behaviors. Now, if you think of it, this is also, again, a good way to think about different research areas. There's a lot of work in public health on knowledge and health literacy, nutritional literacy, a lot of papers written about this. There is a vast bodies of work in motivation and how to intervene on motivation. Behavior change is a rich field. A paper recently came out that listed almost 100 of active behavior change modification techniques. There's less, but still some work on behavioral skills and how to translate general guidelines into daily behaviors. And there is a little bit less on translating this into actual actions. But in my lab, by now, a lot of our work focuses on diabetes self-management, and a lot of it is about nutrition and managing nutrition. And by now, we've interviewed probably more than 100 people with diabetes, and there are some things that keep coming up that don't quite fit with this overarching framework or push it a little bit in new directions. So one thing we're finding repeatedly is that general knowledge of nutrition does not necessarily guarantee self-management of diabetes. Just knowing that it's good for everybody to eat more fruits and vegetables does not necessarily mean you're going to manage your diabetes well. It's a very individual disease. A lot has been written in the last few years, actually, about dramatic differences in individuals' reaction, glycemic reaction to nutrition and meals. This means that in addition to general knowledge, there is a high need for individual discovery, figuring out how one's own body reacts to nutrition. Plus, even when we do that, when individuals can do that, health is only one of the considerations that drives choices in the regular life. There are many other priorities, financial considerations, access, social, cultural preferences, taste preferences. All of those things need to be considered when making lifestyle choices. We were talking earlier today how pushing in the health direction at the expense of taste, convenience, social influences may lead to burnout and decreased quality in life. And ultimately, these solutions are not sustainable in the long run. And then there's a lot written also on the gap between intentions and actions. So there's a lot of cognitive interference. People are busy in their daily lives. So having good intentions does not necessarily lead to following through on those intentions at the time of action. So one way to think for me and for my lab about this is to think about the choices that people make in the context of their nutrition. I don't know how you make nutritional choices, but I typically think about what am I in the mood for? What's available for me? What's convenient? Yesterday I was on a flight from New York. I thought, I fancy sushi. Today there was a great lunch, and that was kind of what the choices were, and it was easy to settle into some decisions. But if you have diabetes, that choice becomes incredibly more cognitively complex. Um, because the question here becomes, what should I eat that is healthy for me personally, which means it's not going to throw my blood glucose levels off too much, that fits my budget, fits my preferences, fits my social constraints, consistent with my cultural preferences, and the list goes on and on and on. And when you think about it, making these kinds of choices requires a lot of mental acrobatics. So if what it means to self-manage diabetes is to engage in that 3 times a day for breakfast, lunch, and dinner every day, no wonder there is a lot of burnout. It's extremely cognitively complex. And perhaps that's why there is a reason to intervene on motivation so much, because it takes a very motivated individual to do that consistently. And I'm going to show you a scary slide, but I'll explain it. It's actually, there's a simple message here. So in my lab, we spend a lot of time thinking about how people engage with complex problems like self-management of diabetes and how they make sense of it. So this is a framework that resulted from some of the qualitative studies. And the main idea here is that when you apply sense-making as a paradigm to chronic disease self-management, it suggests that people tend to operate in something that's called habitual mode. We don't like to spend much time and much cognitive effort on simple solutions, such as choice of meals. And we would rather spend our cognitive efforts on something that is more important, personally meaningful. And then people only engage cognitively when they really have to. So reflection, problem solving are very expensive cognitively activities. And the question or the challenge for my lab and in my research has become to think of solutions, computational solutions that help to reduce cognitive complexity of health management. And the way we've started thinking about this is going from helping structure people's thinking, helping them with tools that make it easier to reflect and learn, and then going to doing some of the reflection and learning computationally and helping individuals make decisions, to even further away to guiding their actions with small and simple recommendations. But not surprisingly, any kind of decrease in cognitive complexity for people is at the expense of exponential increase of computational complexity of the solutions that we're building. And this is where we're starting to think about this transformation from personal informatics, when we expect individuals to do a lot of the reflection and thinking and discovery, to solutions that do a lot of that for them and provide them with decision support and action support. And I'll show you examples for what we mean by those. And the way we do it is with a lot of self-monitoring data, and now with a lot more data science that we can, yes, we can incorporate.
Just a quick question. The only stable assumption here is that you're not removing the human from the loop, right?
We're not.
You could hire a chef.
Yes.
And say, like, you don't worry about cooking, I'll take care of it. And you just eat what I give you.
Yes. So back to the discussion that we had earlier, a lot of this work also is driven by careful consideration of the issues of autonomy. I think to the degree possible, we would like to maintain people in charge and in control. And I feel much more comfortable with solutions that lay out the options and help them choose the option that's more appropriate for them, rather than guiding them towards choices that somebody else thought were better for them. So that's why there is I think we're trying to make this into more of a decision support rather than into behavior modification. So the three areas that I'm going to be talking about, there are several examples of how we thought we could support reflection and learning, and then what we did within making decisions, and also how we started moving more into supporting action. And a little bit about my approach to research. I, academically speaking, grew up in HCI tradition, so a lot of what was used to be called experimental computer science. A lot of what I do is develop novel technologies, novel design solutions, test them in pilot studies to see, is this a good idea? How do people resonate with that? What kind of engagement it inspires? But I'm also at the medical school, which is very concerned with health impact. So every once in a while, we develop more comprehensive solutions, test them in clinical trials with hundreds of people to actually look at whether or not these solutions lead to change in health. And just for fun, we also occasionally study adoption of technologies in the wild. So we did throw some of our technologies on App Store to see how they're adopted in outside of the context of research studies. So back to this, this is also going to be the transition here from more of well-developed solutions with some of the outcomes and clinical studies to more newer solutions where we've done some feasibility studies but don't really know whether they lead to changes in health, to some of the newer ideas where we started conceptualizing but haven't quite gone to evaluation yet. So this is more of a future work area. All right, so let's start with reflection and learning. And the first thing here, again, we're in this space of helping people answer the question of what's a good meal for me? We're working with diabetes. There are some other things that we've done, but I'll focus on this here. if we can help people reflect on their past and answer this question. How can we do that? The first thing that we've tried was to model the cognitive process. So if you think about it, if somebody needs to perform something cognitively challenging, one way to make it easier is to suggest a process for how to do that. So back to that example of multiplying two large numbers, there is a multiplication algorithm. It doesn't make it very easy, but it makes it easier than trying to do it in your head. So if we want our individuals with diabetes to reflect on their experiences with nutrition, is there a process that they can follow? And how can we guide them through this process? So this was a relatively large project. This was funded by the National Institute of Diabetes and Digestive and Kidney Disease. It was a large clinical trial. And it is available online, so if you're interested, you can take a look at it and play with it. The idea there is that there exist several frameworks that describe how this process of reflection and problem solving works. It includes a certain number of steps, and we could build an interactive solution to model this process for individuals. So here are the steps. Identify problems in glycemic control. Keep track of your blood glucose levels and notice where during the day your numbers are not where they're supposed to be. Identify behavioral triggers. What are some of the behaviors that may be contributing to the glycemic problems? And I'll talk in a second about how we did this. Set goals for corrective actions. There are certain behaviors that cause disruption in glycemic control, change behaviors, and then see whether they're changing blood glucose levels. But because this was meant to be used by individuals from medically underserved, low-income communities, low access to technology, and low familiarity with technology, we wanted to make it very simple technologically, so there was not much behavioral tracking in this. And this identifying behavioral triggers, we didn't have any data on what individuals' actual behaviors were. So instead, we used the knowledge engineering approach. We worked with diabetes educators and identified a set of diabetes self-management behaviors that are known to trigger blood glucose changes in blood glucose. So when our users looked at their blood glucose levels and identified problems, we've presented them with a list of possible behavioral triggers and asked them, now think about your own behaviors. Are you engaging in any of this? So a lot of the thinking still needed to happen in their heads. We just gave them the structure for how to think about it. And because it was meant to be a clinical trial, we built it as a relatively comprehensive solution. One thing we've discovered and keep discovering every year is that there's a big difference between testing proof of concept prototypes and developing clinically effective solutions that individuals can engage with over a long period of time. So MOD had a lot of different things. It had motivational messages. It had action plans for achieving goals and a set of reminders for following through on goals. So these are preliminary results, which mean that it worked. Actually, it did make some change, perhaps not groundbreaking, but it had an impact. And we also did qualitative analysis or qualitative studies twice. One was with a random subset of participants of the trial. And then we noticed that, actually almost by accident, that after the trial was completed, there is a part of our participants who are still using it today, every day, which was an incredible discovery. We don't pay them. They're not in the study anymore. They're done officially and they're still using it. So we wanted to understand why. One of the things that came out very strongly is that different people had very different way of engaging with this. For some of them, it was the personal goals that were a really powerful mechanism. They really like setting goals and then working towards their goals. For others, they never set a single goal throughout the whole study, so they ignored that whole goal-setting aspect of it. But what it had one screen that showed them trends in their blood glucose levels, and they started using those as a way for situational awareness. It was a very nice way one of the participants described it, is that he developed a routine. He would wake up in the morning, look at his weather forecast to see whether to take an umbrella or how to dress, and then he would look at MOD to see how he's doing blood glucose levels wise, and how to, if he's running a bit high, then maybe go easier on meals during the day. Or if he's running low, maybe that's a good way to have a good lunch. And then for others, it was this idea of being in a program. It was very interesting. It was almost cult-like description of this, where it was the set of reminders that created a structure for individuals to engage in self-management and stay within that. What didn't work, however, is the process of reflection. Most everybody felt that it was too difficult to sit down and took a lot of effort to kind of think about their past and think about their experiences. It was very cognitively challenging. And that sort of drove us, that was one of the reasons that started driving us in this direction of reducing cognitive complexity. So switching gears a little bit, but still, yes.
Assess any type of like measurement of identity? Did they change the view that how they saw themselves, like from being incapable of tracking to now being capable, or like I'm a good patient versus I'm a bad patient? Did you see
So
any of this like identity
we
change?
looked at self-efficacy. Definitely, there is a scale of self-efficacy in diabetes. Still analyzing results, so I can't comment on that. But yes, we had a quality of life measure, diabetes depression measure, self-efficacy, and one of our main criteria, which is unfortunately extremely difficult to analyze, is the problem-solving abilities in diabetes. So that's still in the works. We're hoping to have the results imminently. So one of the problems with this solution was this idea of I have to reflect on my own behaviors. I have to go back in my memory and think about what is it that I do. Well, the question became, all right, we don't have to ask people to do that. We have all these self-tracking technologies. Why don't we just track things for them? And this was the work of my student, Daniel Feller, who was interested in visual analytics approaches. And his thought was, let's track everything and let's develop visual solutions for people to know, observe the data and perhaps analyze the associations between daily activities and changes in blood glucose levels. But because we suspected that this was going to be a tricky proposition, and because historically we're working, and because of where our hospital is located, we're in, again, predominantly first-generation immigrant, low socioeconomic status community where complex computational solutions are not necessarily the best way to go. So we thought we would start with professionals. And he developed a tool for dietitians to examine patient self-monitoring data and identify those trends. Who has seen a heat map before? All right, fair number, half. All right, so this is a typical heat map that is used in a lot of genetic analysis. Each row here represents a meal. Each column represents a particular variable related to this meal. So here, amount of carbohydrates, protein, fat, fiber, and a change in blood glucose before and after meal. And this is a real data set. It was collected by an individual with type 2 diabetes. The color indicates the amount of, or the value of the variable. So red means a lot, white means average, and blue means very little of. So here, the idea for these representations was to help dietitian notice the changes in color between macronutrients and changes in blood glucose levels. And it was designed as an interactive tool. They could do a lot of things with it. They can sort the data set by different columns. They could select particular types of meals to look at. And here we started introducing some computational analysis techniques. They could also use hierarchical clustering to group meals based on their nutrition and on their glycemic impact. But I'll talk about that a little bit later. But the whole idea here was to help them notice that, well, there is a group of meals at the top where they're very red on carbohydrate, very blue on protein and fat, and very red on blood glucose change. So that means for this person, meals with high carbohydrate, low fat, and protein are not working very well. And then there is another group of blue carbohydrate, red protein, fat, and blue blood glucose are much better meals. So these are the patterns or the trends we expect them to be able to see from this view. And we ran a study where we invited 10 registered dietitians. We showed them two different data sets, one with our tool, one with this more or less table-like presentation, where they would see a picture, they would see nutrition in the meal, and the change in blood glucose before and after. And the caveat here that the data sets being between 60 and 120 meals, this kind of view involves a lot of scrolling. So it's a long data set. And we we asked them to generate patterns, identify patterns. And then we compared what kind of patterns came up from two different tools. What we found, and I'm moving through the results relatively quickly, but there is a paper on this also, you can see more there, is that using our tools, dietitians were able to identify more patterns without any reduction in accuracy. And the patterns were on more patterns about not carbohydrates. So the association between carbohydrates and blood glucose levels is very well known and understood. And basically, with the tabular representation, that was the only thing that dietitians saw. With Glucolyzer, with our tool, they were able to see more of the data set, and they were able to see other patterns that may not be as obvious at the beginning. But they're clearly, yes?
Study whether a particular pattern is a correct pattern or a useful pattern?
That is a very interesting question. So I'll get to it a little bit later. A lot of the things that we do now have to do with computational discovery, in which case whether it's a correct pattern is a very, very hard question to answer. We don't have very good ways of knowing what's true about the world, except for maybe have a gold standard, which is this exactly. It's having experts identify those patterns. So here, we didn't even try asking the question of what's the real pattern there, because there's no way of knowing that. But we did ask them to try to focus on clinically meaningful patterns, patterns that could help them to generate recommendations for their participants. So the two things that came out as challenges here is one, every time I show the first heat map, I see faces in the audience go, it is a complex tool. It took an hour of training for our dietitians to understand how it works, and they wished for more. So we can't even dream of showing something like this to our participants, patients with diabetes. And then another thing that came out as a result of this work is that we discovered an interesting term, apophenia. Who has heard this before? All right, usually I don't have anybody who knows this. So this is a term that is used a lot in cognitive psychology to describe human tendency to see patterns in chaos. As it turns out, as humans, we like our world to be organized. I hope this definition is consistent with how you know it. But there is a tendency, we like to see patterns. We like our world to be predictable. And there is a tendency, again, to impose structure and patterns on something that may not have any structure in it. There's been a lot of work, there was a lot of work in the 80s and 90s to show how individuals may use visualizations of data to identify completely non-existent correlations between different variables. So it's a tricky proposition to show somebody to visualize data for individuals and expect them to identify true patterns. And again, this is what moved us further into the supporting of making decisions. But before we get there, another line of work still in the reflection has to do with helping individuals learn from others. So far, I've talked about tools that are designed to help people learn from their own experiences. But evolutionary speaking, learning from consequences of one's own actions is a very expensive way to learn. Typically speaking, we learn by observing others and consequences of actions by others. So this is a line of work that two of my postdocs, Marisa Burgomaster and Maria Juan, were working on, trying to see how we can leverage observational learning with social computing platforms. And the idea here was to apply it in the context of learning about nutrition. So in diabetes self-management, we're talking a lot about nutritional choices. But to make nutritional choices, first you need to know something about nutrition. You need to be able to say that what are carbohydrates, what is fat, what is protein, and how does it look like, and estimate how much of it is on the plate. So we applied this observational learning to these kinds of questions. And we did two studies. One was done in a crowdsourcing environment with workers in Amazon Mechanical Turk, where we gave them an image of a meal, we gave them all the ingredients in the meal, and we asked them to map ingredients with macronutrients. So what are beans? Is it carbohydrate? Is it fat? Is it protein? Is it fiber? And then we asked them to do it. And then we also showed them how other workers answered that question and distribution of opinions within the community of crowd workers. And our hope was that by exposing them to opinions of others, we can help them learn and improve the accuracy of their own choices. The second study was done, and I'll talk about the results in a minute. The second study of a similar nature but slightly different was done with the Lab in the Wild. It's a open platform for social experiments run by researchers at Harvard University. Uh, this was a collaboration with Christoph Gaius. It's a collaborative set of researchers, but we worked with him specifically. And there we showed individuals two images and we asked them which meal is higher in particular macronutrient. So again, it's a very common question or choice individuals with diabetes face. Which one has more fiber? If I'm supposed to eat meals that are higher on fiber, should I go for the left one or for the right one? And again, here we expose them to how others answered that question as a way of promoting learning. And we compared that with the correctness feedback from experts, which is a typical way of learning, particularly in educational settings. For those of you who are students, you know that you take tests, you get those tests graded by experts, and that's how you learn not to make where your knowledge may be insufficient and where you need to improve it. We could, with and without explanations. We also used correctness feedback from peers and observing answers by peers. And that was our way of modeling observational learning. So in a nutshell, what we found in those studies was for the simple tasks, such as match foods with macronutrients, observing answers by others did just as well as receiving correctness feedback from experts. So it really helped to promote learning. But when the questions were more complex, such as which meal is higher on fiber, the only thing that promoted learning was explanations. So neither correctness feedback nor observing others changed anything in individuals' ability to answer those questions. And it makes sense. If you have a complex meal like that or complex question, you need to know what specifically in that meal contributed to change in macronutrient. But we also found that peer-generated explanations worked just as well as expert-generated ones. So all this suggests that observational learning can be used as a powerful mechanism in social settings. And we're continuing this line of work, looking how to extend it from generic meal to individuals' own meals. But one of the main sort of conclusions from these studies was that yes, we see some improvement and yes, we see modest but detectable effects, but they're still cognitively complex. Only in all of these experiments that we've conducted and all of these solutions, only the most motivated individuals actually continued the engagement. For many participants of the studies, it was too hard, and they really didn't want to do this. They wanted something simpler. This idea of, I just want to know what to eat for my next lunch, continues to be a theme through many of the studies we've conducted. So that moved us more into, all right, fine. Let's focus on that. Let's try to build tools that help people make decisions. And here we're moving from reflection and what is a good meal to something very concrete. I'm about to have lunch. I have my meal choices. Is this a good meal for me? And the way we're doing it is by, again, moving a lot of the processing and computing from people's heads and into the computational inferences with self-monitoring data, identifying different ways to provide decision support and delivering this decision support at the time of decisions. So this work required a lot of data science because now we're doing a lot of the computational inference. And one of the tricky things that we've discovered very quickly is that the kind of data we work with breaks machine learning very fast. It's very sparse. There is just not enough data to make stable inferences. People eat 3 times a day. They don't repeat the same ingredients every day. Nothing simple that we've tried worked very reliably. That's why we started looking into much more complex data science, bringing methods from weather forecasting, from control systems. So there's a lot of collaborations. And I can answer some questions about this and show how we're using these methods in our systems. But the question for my lab, and I think it's more of a HCI question, is to look at, well, what kind of decision supports mechanisms can we provide? And I'll just take a quick step away from the health questions here, because I think these kinds of questions are going to become more prevalent in the HCI community. I don't know about Stanford, but data science is sweeping the world of academia. Columbia has a data science institute. Harvard opened a data science institute. We're talking about AI now. When I was a PhD student, nobody would say that they do work in AI. There is a lot more computational intelligence that is becoming available. But the questions of how do we make this intelligence available to people? What kind of interactive solutions do we build on it? I think there are many open questions there. And I think we started tackling some of these questions in health. I see other HCI groups are starting to think about how do we engage people with predictions? What does it mean to predict future or predict health outcomes? And again, there are a lot of HCI questions around those topics that I hope we will be exploring in the future. I see some questions from the back row there. Feel free to jump in. So the two things that we've tried so far are two specific ways of supporting decisions. Is generating, computationally generating personalized goals and helping people assess their choices on fit with those goals. And second is something that's coming from the theory of planned behavior, is outcomes expectations and it's forecasting. If we can predict the future for individuals and show them how their choices impact their health, can that help them to make decisions in the future? So the first thing we've tried here was some app we developed called Platano, and this is a work of Matt Levine and Elliot Mitchell. And the way it works is that it uses computational discovery of patterns. We're still in the space of nutrition and diabetes self-management. Then what it does, it uses expert system to translate computational discoveries into personalized goals. And then it uses in-the-moment decision support, which in this case takes the form of when individuals are confronted with a new meal, reminding them about their goal and asking them to assess their meal on the fit of their goal. And if the meal doesn't fit the goal, suggesting that they change something about the meal to make it more consistent with the goal. So from the computational side, we used two different methods. We used hierarchical clustering, and we used something which is called attributable component analysis, which is a fancier version of a principal component analysis. But the whole idea here is to identify ranges of macronutrients that have a systematic impact on blood glucose, either mild or lead to high blood glucose excursions. But the problem here is that even if you can computationally identify that, how do you make this useful for somebody? How do you inform them? Showing them graphs like this is not necessarily the best thing. What does it mean and how to incorporate that into a decision? So here what we did is we developed a set of heuristics that would translate those ranges into nutritional goals formulated in the natural language. We worked with diabetes educators and dietitians, and we identified that there are really three things that they could think of that somebody may want to do to their meals. Increase or decrease a particular macronutrient, replace one macronutrient with another. You can say replace half of your carbs with protein. Or because carbohydrates are such a common offender in diabetes, replacing carbohydrates with what's called free foods, most typically vegetables. So these are the most common things, most common nutritional goals one might have. And what we did is that, again, the expert system uses a set of decision rules to generate goals that look like this. For high carbohydrate breakfasts, reduce your carbs to be about one carb choice. Examples of one carb choice are one slice of whole wheat toast, one cup of oatmeal, or one apple. It took us exactly 2 months to come up with that one sentence because it is a very tricky thing to come up with something that is non-contradictory to other nutritional goals, short, and could be understood by a person and could be computed based on the computational analysis that we're doing. And the trick here is that practically every word in the sentence is generated using a set of decision rules. So, and then again, in the moment decision support, I can show you how it works. So we ask our participants to keep track of their meals. They photograph meals. We use a crowdsourcing engine to assign nutritional composition of the meals. And we ask them to track blood glucose before and after meals or at some times during the day to the degree possible. All this data runs through the computational inference engine through our expert system, generates goal like this. Individuals can ignore them or choose to work to select those goals. And then when they take a picture of their new meal, the app will pop up a question. Is this meal consistent with your goal? Yes or no? And if the answer is no, the app will suggest changing the meal so that it's more consistent with the goal. And it keeps track of goal achievement rate. So we did 2 studies to validate these goals. First, we wanted to see, can people even understand these goals? Is it even a feasible proposition? So we did a controlled lab study with 14 individuals from our community. And we didn't want to mess with actual meals, so we gave them food cutouts. But the idea there was to ask them to compose meals that followed goals that were generated computationally. 3 main questions we had. Can they understand the goals? If we gave them meals and told them what the nutrition in the meals was, can they pick the right meal for the goal? Can they pick the right meal when they don't know what the nutrition in the meal is? Just a picture of a meal and find which meal matches the goal. So that's a more difficult question. And if we ask them to follow goals, would they do it in the controlled study setting? So notice that this is not a question, will they follow the goals in their real lives? The question is, can they, if we ask them to? So for a few weeks, my lab turned into an arts and crafts project where everybody was cutting food models out of paper. But long story short, what we found in the study is that when individuals knew what the nutrition in the meal was, they were very good at finding right meals that matched the goals. So at the very least, they understood what the goals were. When we didn't give them the nutrition in the meals, they were not very good at finding what meals match different goals. But when we asked them to follow goals, interestingly enough, they were okay when we asked them to match the goals precisely, but they were very good at moving toward in the right direction. So they may not have matched the exact amount of specific macronutrients, but they made the move in the right direction. So that means that at the very least, they can understand the goals. And if pressed, they can change their nutrition to follow those goals. So we build a tool, we build a smartphone app, And we gave it to 20 individuals and asked them to use it for 4 weeks. And again, this was a feasibility study. So we didn't look at behavior change, and we definitely didn't look at health changes. We just looked at whether it's a good idea and can it work. What we found is that there was I say moderate level of engagement. Truth be told, this was a higher level of engagement that we've seen in any of our previous studies. They were pretty consistent, taking pictures of the meals and engaging with the app. It was an interesting proposition for us because the goals were generated automatically. So we basically kept track of what they were and tried to understand, are these reasonable goals? And we had a diabetes educator looking at them. And then we found the goals were generated relatively quickly, so our computational methods converged on the ranges relatively quickly, which again, we didn't know that that would happen. And then the range of goals covered almost all macronutrients. And what was interesting is that there were different degrees of goal stability. So I'll just show you quickly the transformation of goal for one person. The goals, because it keeps track of individual diet in real time, the goals change, not only based on, for example, based on changes in individual's diet. So for somebody, the first goal was to reduce carbohydrate to about 4.5 cup choices. On the next week, the goal changed to reduce to 4 carb choices. So it starts to, as the individual starts to make changes to their diet, the goals start to be more progressively moving them. So again, one thing here is back to the question of the gentleman in the red sweatshirt there is, how do we know that these are the right goals? The answer is we don't, because there's no truth and we don't way of knowing truth. So we are going to be running a set of studies in the summer to at least assess their face validity and see whether experts would agree with those. But computational discovery always has a question of whether we're discovering something that's really there. And then we ran a set of qualitative studies that at the very least showed that the tool was easy to use and that there was very positive reaction to the idea of pausing during the meal and reflecting on it and thinking about whether it meets the goal or not. So that idea was very well received. The personalized goals were also well received, and particularly the idea of focusing on one macronutrient at a time. This is a very common question. Am I doing okay on my carbohydrates? Do I need to change my protein? So this was consistent with the kinds of questions that people had coming into the study. But what came out very strongly is the need for recommendations. Let's say this meal is not consistent with my goal. So what? What should I do? There was this consistent question of, give me examples of what kinds of meals are consistent with my goals. The next question, I'll go relatively quickly through this. So this was a different way of providing decision support. Generating personal goals still required some reflection and thinking about goals and preparation. And we were looking for lighter weight engagement for individuals. So here, what we did, the idea there was to use the metaphor of weather forecasting and actually use exactly the same methods that are used for weather forecasting. Something called data assimilation combined with the physiological model of blood glucose regulation. This is, again, this is the same type of combination that is used in weather forecasting, whether incoming streams of data allow to personalize parameters of the model. Yes?
Data collected is typically very consistent, right? Because you have an automated tool doing it. Whereas in self-logging, it's obviously incredibly sparse. So what kind of modifications that you need to make to these algorithms to enable them to work with sparse data?
Right. So one of the reasons actually data assimilation works is because of the sparse data. We would not be able to do this kind of inference with any other type of statistical machine learning because there is a lot of knowledge already embedded in the mechanistic model that actually allows to deal in the sparse data environment. In terms of the, so another way to, the first set of methods we were using, I don't know how far I can go in the computational side. So we started with the Kalman filter, where the model learns as it goes through time, so step by step. So this requires quite substantial amount of initial training data to get to good results. What I think we've started transitioning into is something that allows to use simulation, Markov chain Monte Carlo methods to shorten the training period. So there are computational ways of dealing with sparse and irregular data sets. But it's still a very complex process. And our data science team is pushing forward even further in new solutions for that. So very quickly, there is a paper that actually talks about the models itself and how well it predicts blood glucose impact of different meals. But again, from the experience and HCI side, this is the tool we built on this. So let's say I am wondering whether I can have 2 cookies as a dessert after dinner. I can take a picture of the meal. In this case, because I want the forecast right away, I myself enter the nutritional composition the best I can. And then the tool almost right away, within a few seconds, gives me a prediction of how my blood glucose will change if I eat this cookie. If I like this forecast, great. I'm going to go ahead and eat both cookies. If I don't like it, I may remove one of the cookies, take another picture, generate another forecast, and then decide, oh, well, 1 cookie is actually much better for me. So why don't I have 1 cookie? So again, we conducted a qualitative study of this tool. We found with 10 individuals who used it for 4 weeks. And it is available on App Store. So again, if you want to play with it, feel free to download it. What we found is that, again, overall, it was an interesting idea, an interesting proposition. The interesting finding here was that many people used it not in the way we anticipated. So instead of changing the meal itself, they would eat the meal, even if it was a high forecast, but then they would do something else to compensate for it. So they would drink a lot of water after the meal, or they would go for a walk. So they found alternative compensation strategies. But we also found that engaging people with predictions is challenging. And there are many questions still open. For example, when is the right time to show this forecast? By the time the meal is on the plate, it's kind of too late. Many of our participants felt that, the meal is already there. I'm just going to eat it and then hope for the best. How to present this forecast? We just showed them the range. But what we actually generate from the model is a continuous curve. So there is a lot more information we could be showing. But the question is, what is the right amount of it? How to show uncertainty? There are many studies that examined how to communicate uncertainty in weather forecasts, because all computational predictions come with some degree of uncertainty in them. We just presented a paper at CHI on different ways to visualize forecasts for individuals. And again, there's this need for recommendations. When the question is 1 cookie or 2 cookies, it's a pretty relatively simple decision to make. But when it's a complex meal on the plate and you don't like the forecast, what can you do? So that moved us in the direction from making decisions to actions. Can we find a way to actually make very specific, concrete recommendations that don't require pondering different options and don't require quite so much reflection? What should I eat for lunch? And the trick here is there's a lot of work on recommender systems that focuses on generating recommendations based on past behaviors and inferring personal preferences. In the context of chronic disease self-management, this needs to be married with physiological inferences, because recommending people something that they did in the past may or may not be the right solution. So it's a combination of personal preferences and what's right from the health perspective. And the recent work in this space was kind of getting into the space of Alexa. What can I have for lunch? Who has Alexa or any other speaking devices at their homes? right? So you're in the right area for that. So last summer, Elliot, who is a PhD student in my lab, organized a group of students, and they've built a prototype, which is a Alexa skill combined with the messenger chatbot, T2D2. And what it does, it uses exactly the same computational machinery that we developed for other applications to generate personal goals and then search nutritional database to extract recipes that match macronutrient proportions and decomposition that is recommended for this individual. And you can interact with it in a way you can ask, what can I make with chicken and mushrooms? Because that's what I have in my refrigerator right now. And it will search through the database of recipes and will send recipes to a personal cell phone, smartphone app. So they participated in last summer in the Alexa Diabetes Challenge, were selected as one of the 5 finalists. So it was a well-received idea, and we're now starting to enter in the space of user studies to see how would individuals actually interact with a tool like that. So to wrap this up, I think what I was trying to show here is that health management is a complex problem, and the space of solutions can be also very complex. We still need to work on motivation and continue all the efforts on motivating individuals to engage in health behaviors. But I think there is a lot more we can do in helping them to make these decisions easier and reducing the cognitive complexity. And again, I think that these are the kinds of questions that are going to become more prevalent, not only in health, but in many areas of human lives as we start engaging with more data science and more computational inferences. I'm very lucky to work with many excellent collaborators and to be well-funded, but the main credit goes to all the wonderful students that I've been working with over the years. Thank you.
We have a couple minutes for questions.
Yes.
So I found a lot of the results interesting. One that stood out to me was from the reflection learning part, where you found that the people learn just as well from their peers than experts. Do you know why that is? Like, could it have been that people, they don't need as complex information that an expert could provide, and so peers convey it more effectively?
Right. So I think the question was, what are the reasons why people learn just as much from expert-generated explanations than from peer-generated? One thing we found is that, and I think this was observed in educational literature and many other studies as well, is that finding the right words to explain on the same level makes a difference. Expert-generated explanations can sometimes be more complex than is necessary in a particular case. So we found that peer-generated explanations really went to for the most critical part. It's the fiber or it's the peas, and they really were very short and to the point. Expert-generated explanations tended to be much longer and more complex. So I think part of it is that just the language itself could make the difference. Yes.
Not the same results. Like, have also seen any like result that showed peer pressure or something like echo chamber effect, that like people would get it wrong based on their peer and just on their mistakes or something like that.
Right. So this is a very interesting question, and I think that works somewhat differently in regards to something that is a fact versus something that is an opinion. When you deal with nutritional facts, the fact that beans are carbohydrates and protein, there's really not much room for negotiation. It is what it is. So, and we in our studies so far at least only dealt with facts. But once we get to the point of what's healthy, that's where I think the kinds of things you're talking about are going to become much more of an issue, because there can be many different opinions on that, and there could be much more of a pressure from peers and from the community to steer in a particular direction. Even with our studies, what we found that if you rely on observational learning, there is a critical period of formulating the first few opinions. And because of how the studies were conducted, we kind of skipped over that time, that period. But information cascades is a very well-known phenomena in collective intelligence. If the first few opinions steer it in the wrong direction, there is a possibility of the entire community going in that direction. So it is a real danger. There have been some attempts to address this problem. One, there was a work at Georgia Tech quite some time ago to allow those who are more confident in their answers to express their level of confidence. So for example, if you're an expert and you know the right answer, your opinion could be weighted higher than if you're kind of guessing, but you're not entirely sure. Those opinions could be rated lower, but it's still open for exploration. Yes?
Last
Sorry.
question, please. Other questions we can take offline.
Extending on that, do you see any, or have you observed any type of like way of assessing the mindsets around food? Like, there's some work here, or Alia Cram, a psychologist, who says like, he postulates a theory. Says like, if your mindset about healthy foods that's boring, it doesn't matter how much you make all these efforts to think. It continues to be boring and difficult to really adhere to it, right? You may do some efforts at the beginning. You may try to do it, but it continues to be boring. And sadly, there is also some linguistics, research that shows that, at least in the U.S., if you look at the menus of I think Dan Jurafsky did a study on, thousands of menus. He discovered that everything that's high caloric and the bad things that you're consuming, it comes around very beautiful language in the menus, like sizzling meatball, the good stuff, the thing that you should be eating is like, and broccoli, right? So it's like this very boring thing, so it creates this low interest from a desirability as opposed to decision making, which is maybe more ingrained. I don't know if you touch this aspect of how people really relate to food from a let's say more also aesthetic.
So it's a very interesting question. There also have been studies to show that, for example, alerting individuals to caloric composition of meals can have a very interesting and different impacts on different communities. I believe there were studies to show that in low-income communities, we've had the opposite impact, and people opted to buy more high-calorie meals because they considered those to be a sort of a better deal for the same amount of money. I think that there is a way to address that by, again, combining potentially individual preferences or modeling of individual preferences of things that people already like and enjoy and rely on with some awareness of health implications. What's really, and even if you talk to diabetes educators, I think one of the ideas there is making small changes. So not necessarily reconceptualizing how people think about diet and nutrition, but operating within the same set of references, but with small adjustments. So this is where we're trying to go with this. It's not necessarily you need to stop eating the sizzling but just change the portion size or add a little bit of something else on top of it. And if we could get to the point, again, I think that computationally it's going to be challenging, but if we could get onto the point where we can operate within the same language and within the same set of references, we have a better potential of not having to change kind of the paradigm of thinking about nutrition.
All right, we'll take all other questions up here in the front. We'll thank the
All right.
speaker one more time.
Thank you.